Hello students, in this chapter rational numbers we have discussed about what are rational numbers and the closure property for addition, subtraction, multiplication and division for the numbers, whole numbers, integers and rational numbers. In this class we will look at commutative and associative property for rational numbers and all the numbers also. Okay, now we will go for commutative property. Commutative property. What is commutative property? First let me define that so that it will be clear for you. Okay, if I take any number like a and b and if I make any operations on them, if I do any operations on them in such a way that if I interchange the numbers around the operation, the result must be same, then we will say that those numbers and that operation hold good for this commutative property. Okay, like see, this is one way of doing the operation and the other way is this. Let this be any operation like addition, subtraction, multiplication, division. Okay, now this is one way and this is the other way. If I get the same results, then we will say that this operation holds good for these numbers as commutative property. Okay, now let us take whole numbers. Let us take whole numbers. What are whole numbers? 0 and positive numbers, that is 0 and natural numbers. Okay, now what we will check? Let us check if whole numbers are commutative under addition. Okay, now the operation will be addition. Okay, so the examples I take is 5 plus 3. Okay, 5 plus 3 is equal to 8 and the other way is 3 plus 5 is equal to same 8. So a plus b is equal to b plus a. This is for whole numbers. So whole numbers are commutative under addition. Okay, now subtraction. Subtraction. Okay, example B, again 5 and 3. Okay, 5 minus 3 gives me 2 and if I interchange the numbers around the operation, that is 3 minus 5 gives me minus 2. See, this is not equal to this. So a minus b is not equal to b minus a. So whole numbers are not commutative under subtraction. Now multiplication. Multiplication 5 into 3. Okay, why only 5 and 3? Let us take some other numbers. Okay, 6 into 4 is equal to 24 and the other way 4 into 6 is equal to 24. So both are same, which give me that a into b is equal to b into a. So whole numbers are commutative under multiplication also. Now division. For division, 5 divided by 1 will give me 5 and 1 divided by 5, 1 is not divided by 5, so I have to write it like this. Okay, so what we can say, this is not equal to this, which is A divided by B is not equal to B divided by A. So whole numbers are not commutative under division. Now let us let us recap and summarize it in a short. That is, whole numbers are commutative under addition and multiplication, but whole numbers are not commutative under subtraction and division. See, this is for whole numbers. Okay, now we will move on to integers, and the property is same, commutative property. We will check if integers are commutative under addition, subtraction, multiplication and division. Okay, now we'll go for integers and the operation be addition. Okay, if I take integers like -2 plus 5, okay, this gives me 3. And what is the other way? 5 plus of -2. This is integer, this is integer, this is integer, and I got a result 3. And what is this? This is 5 minus 2, which is equal to 3. See, A plus B is equal to B plus A, because we have same results. So A plus B is equal to B plus A, and hence integers are commutative under addition. Now the operation be subtraction. Subtraction, and the example I'll take as 6. Okay, 6 and 6 minus of -4. Okay, the value I will get is, this is equal to 6 plus 4, which is equal to 10, and the other way is -4 minus 6, which is equal to -4 minus 6 is equal to -10. See, this is one way, that is A minus B, I got some result, and if I do B minus A, I got some other result. So A minus B is not equal to B minus A, so integers are not commutative under subtraction. Now multiplication. If I take examples of 5 and -4, okay, this is multiplication. If I take 5 and 4, what I will get? The result is minus of 5 into 4 is equal to -20. Okay, this is one way, and the other way is -4 into 5 is equal to, again, minus of 4 into 5 will give me -20. Now see, A into B I got one result, and B into A I got the same result. So A into B is equal to B into A in case of integers, and what we can conclude, that integers are commutative under multiplication. Now let us go for division. For division, okay, division, I'll take example of simple 6 and 3. 6 divided by 3 will give me, the operation be division, will give me 2, and 3 divided by 6 will give me 1 by 2. Okay, one way I got one result, the other way I got some other result. So A divided by B is not equal to B divided by A, so integers are not commutative under division. Now the next is rational numbers. Next is rational numbers. For addition, we will check for addition. Let the numbers be 5 by 3 plus -2 by 5. Okay, this is a plus b. How to simplify this? Denominators must be multiplied and they have to be written in a common way, like they are common for both the things. Now 5 plus of minus 2. Now 3 when multiplied with 5 gives me 15, so into 5 here, and 5 when multiplied with 3 gives me 15, so into 3 here. This gives me 25 plus of minus 6 divided by 15, which is equal to 25 minus 6 by 15 is equal to 19 by 15. Okay, this is a plus b. Now b plus a. Minus 2 by 5 is b, plus 5 by 3 is a. Okay, same method. 5 3s are 15, and this is minus 2 into 3 plus 5, 3 5s are, so into 5 will give me minus 6 plus 25 divided by 15, which is equal to again 19 by 15. See, both the results are same. So what we can conclude? Rational numbers are commutative under addition. Now we will go for subtraction. Let me take the same examples. Subtraction is minus is the operation. 5 by 3 minus 2 by 5. A minus b. Okay. 15. 5 into 5 minus of minus 2 into 3 will give me 25 minus of minus 6 divided by 15 is equal to 25 plus 16 by 15 will give me sorry, this is not 16, this is 6. Okay, will give me 31 divided by 15. Okay, with a minus b I got some result. Now I will check for b minus a. Minus 2 by 5, this is b, minus of 5 by 3, this is a, will give me 15 minus 2 into 3 minus of 5 into 5 is equal to minus 6 minus 25 by 15, which is equal to minus 31 by 15. See, with a minus b I got some result, and b minus a I got some other result. So a minus b is not equal to b minus a, and hence rational numbers are not commutative under subtraction. Now multiplication. The same rational numbers for multiplication. Okay, let me take some example. 10 by 2 into 6 by 8. This is a into b. Okay, and here I'll get, for multiplication, what is the method? Multiply the numerators, multiply the denominators, and write as it is in the p by q form. So this is 60, 10 6 is 60, and 2 8 is 16. Okay, this when simplified I'll get some answer. Okay, let me simplify. This is 2 8 is 60 and 2 30 is 60, and if I further simplify, 2 4 is 2 15 is, so it is 15 by 4. Okay, with a into b I got some result. Now let me check if b into a is also same. 6 divided by 8 into 10 divided by 2. Okay, 6 10s are 60 divided by 8 2s are 16 is again, see, 60 by 16. So I will definitely get the same answer, that is 15 by 4. So a into b is equal to b into a with rational numbers. So what we can say, rational numbers are commutative under multiplication. Now what about division? For division, what is the case? Let me take some example. 10 by 3 divided by 5 by 6. Okay. Now what is the method? This can be simplified by taking this number on this side by changing the denominator to numerator and numerator to denominator, and change the division sign to multiplication. That is 10 by 3 into 6 by 5. See here, this can be written in this way. 10 by 3 divided by 5 by 6 is equal to 10 by 3 into 6 by 5. See, this is a very simple rule. You can remember it like this. A by B by C by D is equal to A by B into D by C. Okay. See, this D has come on top and C at the bottom, and the sign of division is changed into multiplication. This is the way to simplify this to this. Okay. Now what will be this result? This can be 10 6 are 60 divided by 15, which is equal to 15 4s are 60. So the answer is 4. Now if we reverse it, what happens? 5 by 6, this is A by B. Now B by A. 5 by 6 divided by 10 by 3. Again 5 by 6, and this goes up with the change of sign and the change of places. 3 by 10 will give me 15 by 60, which is equal to 1 by 4. Now see here, A by B is not equal to B by A. So what we can say, A by B is not equal to B by A. So rational numbers are not commutative under division. Okay. Now if you recall the commutative property for whole numbers, integers, and rational numbers, for all the operations, it is something like this. The result will be something like this. Take either whole number, integers, or rational numbers. Okay, they are commutative. All the three are commutative for addition and multiplication. Okay, they are commutative, and for subtraction and division they are not commutative. Okay, this is the simplest way to keep in mind or remember the commutative property and its accordance with whole numbers, integers, and rational numbers. Okay, now we will move on to associative property. What is associative property? Associative property. Okay, if I take any operation, and if I want to operate this with three numbers, that is A star, B star, C. Okay, how can I do this? This can be done in two ways. That is, either the first way is either we will operate this for the first two numbers, and the result which we will get, let this result be x, and this result will be operated to the third number. Okay, this is one way of doing. The other way is we will operate this for the second two numbers, that is B and C, second and third numbers, and the result is operated with the first number. Okay, this is one way and this is other way. And if we get same results, that is if we get something like this, that is in this way we get the same answer as this way, then we will say that those numbers are associative for this operation. Okay, now we will check associative property for whole numbers, integers and rational numbers. Okay, first we will take whole numbers. Okay, whole numbers, and the operation be addition. Let us check if whole numbers are associative under addition. Example B, 5 plus 3 plus 2. Okay, and what are the ways in which I can do it? First 5 plus 3 and then 2. This gives me 5 plus 3 is 8 plus 2 will give me 10. The other way, 5 plus 3 plus 2. The other way is 5 plus 3 plus 2 is 5 will give me 10. So see, both are same. What I can say, A plus B plus C is equal to A plus B plus C. Okay, so whole numbers are associative under addition. Now subtraction. Okay, one way. First way is first two numbers, 10 minus 8 is 2 and 2 minus 2 will give me 0. Second method is this way. Okay, 10 minus 8 minus 2 is 6, so 10 minus 6 is 4. See, this is not equal to this. So what we can say, A minus B minus C is not equal to A minus B minus C. So whole numbers are not associative under subtraction. And now we will move on to multiplication. Okay, example 5 into 3 into 4. First way, 5 3s are 15 into 4 will give me 60. 15 4s are 60. Second way, 5 into 3 into 4 is 5 into 12. 12 5s are or 5 12s are both are same. So 12 5s are 60. See, from both the methods I got same answer. So A into B into C is equal to A into B into C. What I can conclude? Whole numbers are associative under multiplication. Now division. Division, 10 divided by 5 divided by 2. First way is this. 10 divided by 5 will give me 2 divided by 2 will give me 1. Okay, the other way, 10 divided by 5 divided by 2. First I'll do this. 10 divided by 5 by 2 is 2.5. 10 by 2.5, or simply this will be like this, 10 divided by 5 by 2. Okay, now for this, how to do the division. For rational numbers, I have told you division must be simplified in this way: a by b divided by c by d is equal to a by b into b by c. Okay, now see here. What is a by b? 10 can be written as 10 by 1. So this whole thing is like this: 10 by 1 divided by 5 by 2. Okay, so this can be written as 10 by 1 into, okay, no, this cannot be done this way, because with this method we will directly move on to something like this. Okay, now see, 10 divided by 5 by 2. Okay, here 5 by 2 will give me what? 5 by 2 is 2.5, and 10 divided by 2.5 will be 4. See here, with this method I got one result, with this method I got some other result. So what we can say is whole numbers are not associative under division. If you check for integers and rational numbers, you get the same results like that for commutative property. So directly what we can conclude is whole numbers integers and rational numbers are all associative under addition and multiplication, but not associative under subtraction and division. Okay, now